Hello all. In this video, it's a completely new dimension into the open source toolkit from Intel. We are looking at oneAPI toolkit, and we'll be doing the demo in Intel Developer Cloud as well as locally, both of them. So what we are looking at? We are looking at SN1 reaction prediction. That's one of the famous reactions of organic chemistry, and we will do that. So what is an SN1 reaction? An SN1 reaction stands for substitution nucleophilic unimolecular, is a type of chemical reaction that involves a two-step mechanism for substitution of a functional group in an organic compound with a nucleophile. The unimolecular descriptor indicates that the rate determining step of the mechanism involves a single molecular entity. So that's the definition of SN1 reaction. In short, it is a substitution nucleophilic unimolecular reaction where it is considered as a two-step mechanism. Main is the substitution of functional group into organic compounds. So we will just walk along. So what we are trying to do, we are applying oneAPI and using Intel optimized Scikit-learn. We would be predicting if a compound that is being generated is likely to go an SN1 reaction or not. So first what we are doing, we are generating a synthetic data. The function generates synthetic data, creates a set of synthetic molecules by combining a list of base molecules defined by the SMILES notation. You can go back to my earlier videos, you can see like what is a SMILE notation itself with a set of functional groups. For each generated molecule, it checks the validity using RDKit, calculates two molecular descriptors, molecular weight and log P, and assigns a random binary outcome 0 or 1, representing whether the molecule is likely to undergo SN1 reaction. This is a very important part. That is 0, we are representing it as either on 0 or 1 in terms of accepting it will go SN1 reaction or not. The data is then compiled into a pandas data frame. We are training the model using the Intel optimized random forest classifier from Scikit-learn to predict the SN1 reaction likelihood based on the molecular weight and log P descriptors. The model can then be used to predict the reaction likelihood for new molecules. We are also calculating the descriptors. That the calculate descriptor function computes the molecular weight and log P for a given molecule. These descriptors are crucial for model to make prediction. Visualize the molecule also using RDKit's drawing capabilities. The visualize molecule function generates an image of the molecule from SMILE string and displays it within the Intel Developer Cloud Jupyter notebook that we are using. This visual aid helps in understanding the structure of the molecule being analyzed. Then there is an interactive input and prediction. So let's directly go into the demo itself. So we are here at the Intel Developer Cloud. First of the things that we did was install the RDKit. We are using the base toolkit. So if you want to use this base toolkit, what you need to do is just click on this plus icon, then use this notebook base that's there. I'm using the same. The kernel used over here is base. You're not switching in the switching the kernel itself. We kept it in the base. We have installed the RDKit. RDKit is installed so that we can use all the components of organic chemistry, visualize them or do some functional work on it. Then we initialize the NumPy as well as Scikit-learn. The Intel extension for Scikit-learn is enabled. We have initialized we have bought in NumPy widgets. Here we are generating the synthetic data as been mentioned with the base SMILE groups and the functional group, and assigning them with SMILE's molecular weight, log P values, and SN1 reaction that we have mentioned like 0 and 1. We are using a random classifier, making a state of 42, and we are just sending it back, calculating the descriptors, then visualizing the molecular. The most important part is here where we are using different kind of SMILES for it. See this widget that's been created, it also shows that this molecule will undergo an SN1 reaction or not. I will take one of the compounds in here, So I'll pass it along, say CCC base miles that are there that we have built upon. uh, let's do that and see. It says that it's unlikely to go an SN1 reaction. I'll check with other compounds too. Okay, and let's check this also. These are all the base miles that we have used. So again, this one is also undergoes molecular weight is given log 2 values as well as is unlikely to go and SN1 reaction. So that's the synthetic data created, and we can also choose between these values. So we have done the entire application in Intel Developer Cloud and also create a widget where we can pass in smiles, see the values, and also predict that if it is unlikely or unlikely to go on SN1 reaction. We'll see the same using Streamlit. So we'll just open it up over here. I have the code written for it for the SN1 prediction itself. What I would do is just use it or run it over here. I will just check for it. dir so Streamlit run SN1 prediction .py. Just open it up in Chrome. Okay, so here one additional capability is there that you can directly select this and it would generate the synthetic data, and you can pass in different compound like CC BR, enter, which shows is unlikely to go. The similar thing that we created in Developer Cloud IDC, the same is being replicated as a web app, or you can say the Streamlit app locally. So I have shown the entire application running using oneAPI toolkit, using the Intel optimized Scikit-learn, and also we are doing predictions for SN1 reaction. So it's one of a kind application that we have built. The code I have used is completely open sourced. You can take advantage of it, and I am using the normal module of the Intel Developer Cloud. It's the same instance. I'm not using any GPU in this, so anyone can get started while taking this advantage of this code itself. Thank you and happy coding.